Hello, this is Ken from the Computer Clan, here today to give a little lesson on what bits are. I've done some videos of this in the past, but people have been begging for more information and for other facts about bits, so I decided to go back to the basics and then elaborate. So, first of all, we're going to talk about what do bits equal? What exactly is a bit, and what exactly does 8-bit equal, or does 16-bit equal? We'll talk about how we use them in our everyday lives, and we'll also talk about computing. What is the difference between 32 and 64-bit computing? Let's start with some numeric values. We may know what binary is, bi meaning 2, and binary is two numbers, ones and zeros, and they are represented with zeros and ones in a row like this. So 1 bit is one binary number in the first position, which equals 1, so in decimals that is 1. If we go to 2 bits, that adds 2 binary ones, and that equals 3. The same thing continues. If we move to 4-bit, that is 4 ones, the decimal equals 15. So these numbers up here, they go 1, 2, 4, 8, and they keep doubling, and each binary 1 triggers one of those values. So if there's a 1 in the second position, that equals 2. If there's a 1 in the third position, that equals 4. It just keeps doubling up the more ones you go to the left. You take those numbers from the binary value and you add them together to get your decimal value. In this case, we have 1, 2, 4, and 8. If you add those together, you get 15. Now we'll take a look at a pretty common value, 8-bit. All binary ones in the first 8 digits. When you add all of those values together, you get a decimal of 255, but including 0, that gives you 256 values. There is a very simple formula for calculating the base 10 decimal value of bits. All you do is you put bits in for x, and that is your exponent to the number 2, and y equals your decimal value. So you take 2 to the power of your bits, and that gives you your y, which is your decimal value. For example, let's calculate how many values we can get with 4 bits. You take 2 to the 4th power, which is 2 times itself 4 times, and when you multiply that out, you get a value of 16. When we did our binary math, we got 15, but remember, that is not counting 0. When you count 0, you have 16 values. Now let's get into something more fun, color depth. Take a look at this Macintosh SE screen. It looks like it's black and white, correct? However, it is not grayscale black and white like in a movie. It is literally only black or white. This is a 1-bit display, and this image resembles that. You get 2 color values, in this case, solid black or solid white. The images are rendered with these 2 color values by placing the dots closer to each other where they need thicker blacks, and further apart where they need grays, and in no places at all where there are whites. It is kind of like printing on a newspaper. Let's take a look at a 2-bit rendering of that same image. We now get 4 color values. You see this kind of blue, this kind of pink, and this green and black. So the image can only be rendered with those 4 colors because the 2-bit addressing only has 4 values. If we pump it up to 4-bit, we now have 16 colors. So we have more variation in the colors, thus rendering a higher quality image. It still doesn't look perfect to us because we're used to seeing higher quality color. Here is an 8-bit rendering of that image. That is 256 colors. As you can see, it is pretty darn perfect, and you're probably not going to see much of a difference between true color and 8-bit while streaming this video over the internet. True color, using 24-bit color, gives us 16,777,216 color values. This image is using true color. And keep in mind, the human eye can only discern about 10 million colors, so this is a pretty good safe point. Let's take one more look at the difference in colors on a computer monitor. This Color Classic Macintosh is using 256 colors. Note the color palette. When we switch to 16, you can see much fewer colors are displayed on the screen, and when we switch to 4, it is only using black and white because it would be pretty hard to get 4 colors that look good to the human eye to mix together. And pure black and white is 1 bit, only black and only white values mixed together. When we switch back to 256-bit, we get all the colors that this 8-bit display can produce. Audio depth follows the same basic principles, except it is used for audio, of course. Here's a square wave graph of 2-bit audio. It has 4 different quantization frequencies. In layman's terms, this can only produce 4 sounds. I am sure a lot of us have heard 8-bit music before. This is also known as chiptune music. 256 values means you can have 256 different types of sounds with 8-bit music. This quality is a lot higher than the 2-bit music we looked at previously. Basically, the more bits you have, the more sounds you can produce. The music we listen to today is typically 16-bit audio. That produces 65,536 sounds. So the quality is much better of what we hear today than what we heard back in the 80s, let's say, with 8-bit audio. Now we come to the subject that I get asked about a lot and that I have done videos on previously. 32 bits allows a value of about 4.2 billion bytes. 64 bits, on the other hand, offers a number that is so astronomically huge we have to write it in scientific notation most of the time. Now, how are these bytes useful to us exactly? Well, if you're running a 32-bit OS, you're typically restricted to about 3.25 gigabytes of random access memory. That is the memory in your computer that helps applications run faster, and it allows you to run more applications at once because you don't have to load information from a hard drive. However, a 64-bit OS can support up to 16 exabytes of random access memory. That is about 17.1 billion gigabytes. So it is virtually unlimited since we have not created personal computers that use this amount of RAM, but supercomputers could really use this type of space, especially in the future. To put it simply, more RAM results in faster multitasking and less disk activity. The RAM can act way faster than the hard drive can, and then when you do that, you can load things much faster than having the disk constantly go back and read information. So maybe you're using an older system, or you're not even sure what you're using exactly, and you want to find out how you can make your computer faster, or you want to find out what type of architecture you're using. Essentially, to have the 64-bit experience, you need a 64-bit CPU, a 64-bit OS, and it's recommended you have over 4 gigabytes of RAM. If you are a Mac user and you have a processor that is an Intel Core 2 Duo or up, you're already set to go. You have a 64-bit system. If you are on Windows, check that your CPU has 64-bit architecture, and check what version of Windows you have installed. Microsoft provides 32 and 64-bit versions of Windows. You can find out more information in the System panel in your Control panel.
Young English Engineer. Your way to the electronics world. Like our Facebook page and learn more. Project provided by Tesla Institute. School of Electrical Engineering and Automation.